Hello everyone. Hi, how are you all? Good evening. So if you can hear me, you can just say yes. Can you hear and see me, everyone?
Can you hear and see me?
Okay,
everyone?
that's awesome. Great. So did you get some time to attempt today's question? How many of you were able to at least read the question? You can say yes if you could read and understand the problem statement. Okay, Ranveer is saying that he read but couldn't solve. Vishnu says yes. Faizan says yes. Okay. If you ask me to give my honest opinion, then this is a very beautiful question. This is, I would consider it as one of the best questions. Why? Because it's a difficult question. First thing, it's a difficult question. At the same time, it's not that kind of difficult question which requires you to have knowledge of some fancy data structures or algorithms. By that I mean it does not require to it does not require for you to know about maybe segment trees or lazy propagation or convex hull or any such sorts of complicated concepts. It just requires you to have the right knack of algorithmic thinking, the right knack for algorithmic thinking. That's all. Okay, so it's a really beautiful question. The solution to it is also very simple, and thereby the code is also very simple. But the ideation phase, where you ideate the solution, that is the most beautiful aspect of this particular problem. Okay. So without any further ado, I think I'll quickly read the problem statement once for everyone. So it says that you are given an integer array called as nums. We have nums, and in one operation you can replace any element in nums with any integer. So it means that let's say this is our array. Now I can literally pick any element and I can literally change it to any other element. So if I want, I can convert it to 800. If I want, I could have converted it to 0. If I want, I could have converted it to 9. Whatever, it's up to me. So I can literally pick anything and convert it to anything, and that will be counted as one operation. One. Okay. Now, nums is considered to be continuous if both of the following conditions are fulfilled. Okay. So let's read these conditions. The first condition is that all the elements are unique. So a continuous array is that in which all the elements are unique, but this is only the first condition. Okay. The second condition is that the difference between the maximum and minimum is equals to length minus 1. Okay, now think of it in this manner. If I give you any random array, let's say there is a random array in which elements are continuous. Let's say you have 3, 4, 5, 6, 7. Now what is the size of this array? What is the length? 1, 2, 3, 4, 5. The length is 5. Okay. And what is the value of max minus min? In this array, the maximum element is 7 and minimum element is 3. So 7 minus 3 is 4. And is that not equals to length minus 1? The answer is yes. So I can say that the difference of maximum and minimum element is equals to length minus 1, where length represents the length of your array. Now, one thing is very, very intuitive. What is intuitive? That if you really have a continuous array means which contains continuous elements, consecutive elements like that, then in such a kind of the array, the difference between max and min will definitely be equal to length minus 1. Is everyone clear with this idea? Yes or no? The idea that says that if you have a continuous array, then the difference between max and min is going to be length minus 1, right? Okay, very good. That's one point. Another point, however, is that if you read the first statement, it says that all the elements should be unique. This is super important. If you're asking me why this is super important, if I convert this 4 into 3, still the difference between 7 and 3 is 4, which is equals to length minus 1. But that doesn't make it eligible for a continuous array. So continuous array is that in which all the elements are unique, and on top of that the second condition that you can see here holds. Does that make sense to everyone? Now there is one more thing that I want you guys to know. These elements could appear in any jumbled up order also. So what I mean by that is you could have something like 4, 7, 3, 5, 6. So even this array is a continuous array for me because it follows this rule in which you can see that every element is unique, and it follows the second rule also in which you can see that the max difference the difference between the max and min 7 minus 3 happens to be 4, right? And if you read out the elements, you will read them like 3, 4, 5, 6, 7, and what are they? They are consecutive, they are continuous, right? The only thing is that it's a jumbled up version of the previous one, and there is nothing, I don't have an issue with that basically. Okay, cool. So so let's look at the question. The question says that what we have to do is we have to return the minimum number of operations to make our array continuous array. This is the question. So you will literally be given any random array. Now what you have to do is you have to perform some operations to make it continuous. But you have to tell me the minimum number of operations. You don't have to tell me the maximum number of operations. So and what is an operation? We all know that an operation comprises of picking up literally any element and changing it to literally any other element. Okay, that's the idea. So how many of you are super clear with the problem statement now? Especially those of you who had not read the question, or maybe you read but could not understand it on your own. Are you now comfortable with the problem statement? Does that put us on a platform where we can now start ideation? Yeah, awesome, that's great. Okay, so let's move on. Now guys, when I look at this problem, it is worth noting that if we take some examples, then the life will be super easy. So let's say I take an example that says we have 6, 7, 8, and let's say 10, 11. So let me jumble it up a bit. It needs not be in ascending order, it can be in any order. Now I want you to understand one more thing, that you can have duplicates also. Here I am not having duplicates, but it can have duplicates. Let me tell you that. Okay, so what should be the answer for this case? What is the minimum number of operations that you would want to do in this case? Okay, one of you is saying, can we apply cycle sort by getting min and max? Keep this thing in your mind that the elements that you have can be anything. In fact, you have duplicates also. So it will be worth elaborating your cycle sort algorithm, then only I can stamp it as right or wrong. Okay, cool. So in this case, some of you are saying that the answer is 1, some of you are saying that the answer is 2. Those of you who are saying that the answer is 1, can you tell me which element you are converting and what is it that you are converting it to? What if I convert this 11 to 9? Yeah, as Vishnu is saying. So if I convert it into 9, what will happen? Your end product will be this. Now is this a continuous array? Yes, just look at it. It has 6, 7, 8, 9 and 10. So the answer over here should be 1. Just one operation does the job. Some of you said that the answer is 2, but those of you who said that the answer is 2, can you see that 2 is not the right answer? The right answer is 1 actually. Correct? Okay, I would say one thing guys. For a moment, let's forget about this constraint which asks you for minimum number of operations. Can I say that, hey, no matter what kind of input I have, it is always possible to convert it into a continuous array. It is always possible to do so, provided I do not have any limit on the number of operations, isn't it? The answer is yes, because in the worst case what I can do is, in the worst case I can say that, hey, I'll convert the first element to 1, the second element to 2, the third element to 3, the next element to 4, and the next element to 5, and the job is done. So the point I'm trying to make is that it is always possible to convert your given input into a continuous array, right? And in that case, how many operations you are performing? You are performing n operations, because in that case you are literally changing each element so that continuity is observed. Now let's think about one thing. Let's get it back to however it was. I think it was 6, 7, 11, 8 and 9. Tell me one thing, guys. Can I say that, hey, instead of performing n operations, I could have performed n minus 1 operations also. N minus 1 operations regardless of what kind of array I have. Regardless of what kind of array I have. And if you are wondering why I am saying that, because I can pick any element as my reference element. When I say reference, I mean as my reference minimal element, and then I can adjust other elements accordingly. For example, if I fix 11 to play the role of smallest element, then I can change something else to 12, something else to 13, something else to 14, and something else to 15. So the point that I am trying to convey from here is that no matter what is your input, you will never need n operations. Doing n operations is a stupid idea. Why? Because we can do it in n minus 1 operations also. So if you are doing n minus 1 operations, it implies one thing. What it implies? That at least one element will remain unchanged. At least one element of your input will remain unchanged. The element that you have picked as your reference element. This is the most important observation to get started with. Is it making sense? Yes or no? Yeah. So we can say at least one element is going to remain unchanged, and you can see that in any example, like let's say here in this case you did not need to do any operation because it was already continuous. Here in this case they say that this is one result that you can have, and you can see that element like 1, you can see 1, it has remained unchanged. You can see 2 also, that also has remained unchanged, but the basic idea is that at least one element is going to remain unchanged. That is for sure. Now this will start giving you a lot of clues. Okay, a lot of clues. See, I had already assembled a different example, 4, 5, 8, 9, 10. What will be answer for this case, by the way? If this is your input, then what is the minimum number of operations that you would want to do? So there are so many things that can come to head. Somebody can say, hey, let 8, 9 and 10 remain as they are and convert 4 and 5 into 11 and 12. So that way you will get 8, 9, 10, 11, 12. And how many operations have been performed? 2 operations. Okay. Somebody else can go on to say that I'll not touch 8, 9, 10, but I'll convert 4, 5 to 6, 7. Because 6, 7, 8, 9, 10 is also continuous. If you are saying that 8, 9, 10, 11, 12 is continuous, so is this also continuous, and in this case also the number of operations performed were exactly 2 operations. Okay, and I can also say one thing, that I can change 9, 10 to 6, 7. If I do that, I'll have 4, 5, 6, 7, 8. This is also continuous, and in this case also there are 2 operations. So what I am trying to show you is that there can be multiple ways, but across all those ways the number of operations is same only, 2, and that is what the answer is. Now let me show you the most important aspect. No matter which array you touch, which transformed array you touch, it does not matter. You can see that at least one element stays the same. Like here 8, 9, 10 stays the same. In this case, if you look again, 8, 9, 10 stays the same. In this case, lot many elements stay the same. Now lot of you should start somehow approaching to the solutions. So Shivam is saying we can stay with those max elements which is continuous. Okay, anyone else who is getting some intuition from here, from this particular idea? Think of it in this manner. Just think of it in this manner. You want to create a continuous array. The size of that continuous array should be n. Okay? You can just focus on what I am writing because this is very, very important step, guys. So you need to be super focused. So you want to create a continuous array of size n. Let's say the minimum element is min. Then can you tell me what should be the maximum element? Or can you express the maximum element as a function of min and n? Just think about it. It should be min plus n, or it should be min plus n minus 1? Tell me. Because the question says that the difference between max and min should be equals to n minus 1. That means if your min is fixed, then your max should simply be, you can figure it out, right? Yeah. So most of you are right. So it should simply be min plus n minus 1, as simple as that. So max will be equal to min plus n minus 1. Now guys, I want you to think about one very, very simple thing. Super simple. Let's say somebody tells you that, hey, in your result array, the minimum element is 8. Somebody magically tells you this thing, okay? That, hey, in your result array, the minimum element is 8. So all that you know about is minimum element, that is 8. If minimum element is known to you, can you find out maximum element? Come on, tell me what will be the maximum element. If the size of array is 8, if the size of array is 5 and min is 8, what should be your max? Your max should be 8 plus the size of array minus 1. And what is the size of array? It's 5. 5 minus 1 is 4. So plus 4, 8 plus 4 is 12. So what I know is that if my minimum element is 8, then my maximum element has to be 12. So I know for sure that in my resultant array, the elements will be 8, 9, 10, 11, 12. This is all that I know. Correct? Now, if I know that in my result array, the elements will be 8, 9, 10, 11 and 12, would you want to delete these elements if they are present in this array? Would you ever want to delete them? No. Would you want to change them? Would you want to operate with them? No. So what I can say is that, inside this array, I'll only transform those elements which do not fall in this category. Now, how many elements in this array do not fall in this category? Only 2 elements, which are 4 and 5. And that is the reason our answer is 2. So to wind it up, if I tell you where we started from the idea that if somebody tells us the minimum element, then we can derive the maximum element, because maximum element will be minimum plus n minus 1. Now all that we have to do is we have to check that how many elements in this do not fall in this range. And whatever is the count of that, that will be answer. So Shivam is asking a very good question, that what about duplicates? Think about it. I'll talk about it in some time to come, but think about it. However, the job is not yet done. Why the job is not yet done? Because I told you that for now some magician is going to tell you the minimum element, but there is no magician, right? So we have to somehow get to know the minimum element, right? So what will be the minimum element? Can we somehow figure out the minimum element? And can we do that with ease? Just think about it. Okay. Gladiator is saying, what if the minimum element is the only one which is making the complete array non-continuous? Okay. Let's just see that. However, as I told you, we have still not figured out what our minimum element will be from an input. Okay. Okay, so let me just explain this thing. Do you guys remember this point? The point where I told you that at least one element of the array will remain unchanged, right? At least one element will remain unchanged. Now, is it correct to say that this also implies that the smallest element will be some element of original array? Is it correct to say that smallest element will be some element of the original array based on this thing? Let's take an example. When you look at this, what is the smallest element here? The smallest element is 8. And is it one of the elements of original array? The answer is yes, it is. Okay, look at this array. What is the smallest element here? The smallest element is 6. Now, is it one of those from the original array? Is it one of those from the original array? Tell me. No, the answer is no. It is not. It is not. So this particular conclusion is not right. Okay, in this case, once you look, the smallest element is 4, and the smallest element 4 is one of the elements of your original array. Now, you know, there is one important thing that you guys have to understand. Sometimes, in some of the results, I am able to see that the smallest element is one of the elements from original array, like in this case and that case, like the smallest element was one of the elements from original array. But in this case, that does not hold. Now the point to understand is that, hey, even if you have a result like this, where your smallest element is not one of the elements from original array, then I can say it is very easy to transform some other set of elements. Like instead of transforming 4, 5 to 6, 7, I could have transformed 4, 5 to something like 11, 12. And if you now this is something which requires a greedy thought process to prove whatever I am saying, why that is right. So let me explain it to you. Let's say you had an array, okay, and the array had some elements inside it. So I'll take this array itself as an example. 4, 5, 8, 9, 10. Okay. Now what you did was you transformed this array into this thing, which is 6, 7, 8, 9, 10. Okay. And you will say that, yeah, this is the transformation which gives me my answer, that is 2. Correct? Now I'll tell you one thing. Here the smallest element is 6 and 6 is not present here. Okay? If 6 is not present here, can I say that 6 must have been created by transforming some element from this array? Yes or no? And that is the case. You transform this 4 into 6, correct? Similarly, if you move on, you encounter 7. 7 is not present in this array. So can I say that 7 also must have been created by transforming some element from this array? The answer is yes. 7 was created by transforming 5. Now you encounter 8, 9 and 10. Now think of it in this manner. Even if we kick these elements out, we can think of it in this manner that 4, 5 could have been transformed into the elements that come after 10. So instead of transforming 4, 5 into 6, 7, we could have transformed 4, 5 into 10, 11. And in that case also, I could have easily gotten a continuous array. And it's very important to understand this point. Could you relate to it? It's a little tricky, so I can go on explaining it again 2-3 times till you get it completely. But how many of you got it? You can just say yes if you are able to get it. Very simple and very neat, isn't it? Okay, so I'll go by it again. See, this was your input, and let's say you transformed it into this, and thereby you performed 2 transformations. You transformed your 4, 5 to 6, 7, correct? Till this everyone is clear, right? Now, all that I am saying is, in this case, your smallest element is 6, and 6 is not present in your input, correct? So I'll tell you one thing. Let's start iterating on this array from beginning. So the first element is 6. 6 is not present. What does it mean? It means that 6 must have been made out of something. And what is that something? It is 4. You converted 4 into 6, correct? Now move on to the next element. The next element is 7. 7 is also not present. Because 7 is also not present, so I can say the same thing for 7, that 7 also must have been made out of something. And what is that something? That something is 5. As you are walking from left to right, you might encounter an element which is actually present in the array. And what is that element? That element is 8. So now you can stop and say that, hey, these elements which have been produced by transforming some elements can be kicked out, and instead of transforming 4, 5 to 6, 7, I could have transformed 4, 5 to 10, 11. Sorry, not 10, 11, I mean 11, 12. In that case also, my result would be 8, 9, 10, 11, 12, which is continuous in nature, and the number of operations would have been exactly 2. So the point is that if your result array does not start from an element which is already present, then in that case, the other way around is also possible. I mean, some other possibility is also possible. And what that other possibility is, instead of transforming these elements to be behind them, you could have transformed them to be ahead of them, which is 11, 12. So I can say it for sure that definitely I'll have a result in which the smallest element will be one of the elements of the array. I don't know what that element could be. The smallest element could be 8 also, could be 4 also, like here it is 4. It could be 10 also. I don't know what, but it is guaranteed that the smallest element will definitely be some element of the original array. Which element of the original array, I don't know, but some element of original array for sure. Yes, yes. Does this proof make sense? How many of you have been able to understand this proof? You know, in data structures and algorithms, usually when people learn greedy algorithms, no matter how they learn, what they usually do is they tend to remember the solutions. But you know, the real beauty lies in the proof of those greedy solutions, that hey, why it is right. See, even if you look at the solution of this problem in the tab, they have not explained it. They have not explained it there, that why the smallest element will be one of the elements of the array. But it is very important to understand. I mean, I could have easily told you that, hey, let's assume this statement is true and then let's work on top of it. But assumptions are not right. If you're doing maths, you have to prove it. And now we have proven it. We have proven it very correctly that, hey, it is guaranteed that the smallest element will be one of the elements of the array. So we needed to arrive till here, and beyond it we can start thinking. So is it clear? How many of you are now absolutely clear with the truth of this statement? Anyone who is still 10% not clear, 5% not clear, can let me know, and then I can do that again before we jump into the coding part. Right? Okay, great. So now I can say, let's say we have been given an input. It looks like 14, 12, 10, 9, 6, 8, 11, something like this. Let's say this is your input. And let's say it has duplicates also, because somebody asked about duplicates also. Let's say we have 8 also, we have 11, and then again 12. If I have to work on this, what I can do is, I can say that, hey, it is guaranteed that the smallest element will either be 6 or 8 or 9 or 10 or 11 or 12 or 14, because we just proved that the smallest element will be some element of the original array. Now let's perform our trial 1. Trial 1 is to consider 8 as the smallest element. Tell me, if 8 has to be the smallest element, in that case, let's have some bigger data also. Let's say it was 22 and that was also 22, just for example. Let's say if 8 is the smallest element, then what should be the maximum element? What is the size of array? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So if 8 is the smallest element, the largest element should be 8 plus 10 minus 1, which is 17. Good. So I can say that I just want to secure those elements which are in between 8 to 17. But should I consider duplicates also? Like if 8 is coming twice, should I secure both the occurrences of 8? No, I should only secure one occurrence of 8. Similarly, if there is an element 9 which is coming 5 times, I do not want to secure all the 5 occurrences. I only want to secure one occurrence. Okay, so when I look at this 8, I will secure this one occurrence of 8. I have a 9, so I have one occurrence of 8, I have a one occurrence of 9, very good. I have a one occurrence of 10. Do I have an 11? Yes, I have an 11 also. Do I have a 12? No, I don't have a 12. Do I have a 13? No. Do I have a 14? Yes, I have a 14. So plus 1 for 14. Do I have a 15? No. Do I have a 16? No. Do I have a 17? No. So I can say 1, 2, 3, 4, 5. 5 elements from this array should remain as they are, and all the other elements should change. So can you tell me how many elements should change? The size of this array is 10, and if 5 elements should not change, then how many elements should change? It should be 10 minus 5. So I can say it from here that if 8 were to be our minimum element, then the answer would be 5. But it's not guaranteed that 8 will be our smallest element, because we have said that the smallest element will be some element of the original array. So instead of 8, it could be something else also. What if it was to be 6? So trial 2 can go for 6. So if 6 has to be the smallest element, what will be the maximum element? It will be 6 plus 10 minus 1, which is 15. Now we will check how many elements in this array are in between 6 to 15, and we will only secure their one occurrence each. And we will subtract that from the length. We will keep on doing that with all the elements of the array, and whatever is minimum answer in that would be our answer. Does that make sense? How many of you are absolutely clear with the idea? Right? Simple enough, and see how beautiful the question was. Now, so till now we have not, you know, uh, talked about the algorithm in steps, that what will be the first step, what will be the second step, and all such sorts of things. We need to do that very easily, right? So answer me one thing. In this question, what is it that you're supposed to do? You're supposed to check that how many elements in the array are in a certain range, right? This is what you want to check. Now, if you want to check that, then which algorithm do you think would come handy? Which algorithm will make your life easy to do so? So let's say if I give you a sorted array, the sorted array is 10, 12, 13, 16, 22, 34, 45, 56, and 100. Now, let's say you have been given a number, num, that is 17. Let's call it target. And if I have to check that how many elements in this array are smaller than equal to 17, can I do that using binary search? Can I? The answer is yes. I can apply binary search on this array, and then I can find out the index of last element which is smaller than equals to 17. So I can say that beyond this everything is greater than 17. This is the first index, this is the last index where elements are smaller than equal to 17. So I can just compute the length from this index to that index, and that length will tell me that how many elements are there in a certain range. So if I somehow sort this data, then my job will be super easy, isn't it? Do you understand why sorting would make my life super easy? Because that way I can very easily, so if you sort this data, what will you get? Let's say somebody sorted it for you. You will get 6, 8, 8, 9, 10, 11, 11. What comes after 11? 14, 22, 22. Did I consider everything? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I did. So now the job is super easy. So I can say that what I can do is that for each number in our array, what can we do? We can consider that number as our min, right? Min equals to number. And what will be our max? Our max will be number plus n minus 1. And now all that we have to do is we have to binary search for the last element that is smaller than or equal to max. Like in this case, if you consider 6 as your minimum, then your maximum will be 15. So all that you have to do is you have to binary search for the last element which is smaller than equal to 15. But if you have duplicates, will you get the right answer? The answer is no. Why? Because I already spoke about it, that we just need to secure one occurrence of 8, one occurrence of 11. So will it be a great idea if we first remove the duplicates? If we remove the duplicates, the life will be super sorted. Let's say there are no duplicates at all. If there are no duplicates at all, there are no problems at all. Because now, if I know this is the index of 6 and this is the index of 14, then the difference in between these two indices will actually tell me that how many elements are there which are in the given range. Correct? Yeah, so that's the idea. What's the idea? We will remove the duplicates, and then one by one we will pick each number as minimum. That will give us maximum, and then we will binary search for maximum, and that will give us that how many elements should be unchanged. If we know how many elements should be unchanged, just subtracting that from the length will give us how many elements should be changed. And based on that, we can create our answer. Okay, so is it clear now? How many of you feel that now you're so clear that you can even go on to code this idea? Why did we remove the duplicates? We removed the duplicates because let's see what is the requirement. All the elements in your answer should be unique. Now, if you are picking your smallest element as 6, that means your largest element should be 15. Now, if you have to count how many elements in this array are in between 6 to 15, in that case, you don't want to consider 2 occurrences of 8 or 2 occurrences of 11. You only want to secure one occurrence of each element. That is the reason, to make things easy, I got rid of all the duplicates. Does that make sense? Yeah. Okay, awesome. So finally, what I'll do is, I think I have a code which is pre-written. So why don't I show you that code itself? Yeah, let's see this code. It will make a lot of sense now. So let's look at the code step by step. The first line is I have sorted the array. After sorting the array, it becomes easy to remove the duplicates also, isn't it? Because think of it in this manner. If you have a sorted array and you want to remove the duplicates, then all that you have to do is you can create another array, temporary array, and as you are iterating, if you see that an element is same as the behind element, you can skip taking it. And if it is different than the behind element, then only you take it. So that is the algorithm that I am going to write. So I sorted the array, then I created a vector of integer uniques where I am going to only secure the unique occurrences. Of course, the first element will be unique element, so I'll push it inside the uniques vector. And then moving onward from first element till the end, my logic says whatever I explained you. I'll compare the current element with previous element, and if it is equal, I'll not do anything. Only if the current element is not equal to the last element, that means it is unique. So I'll put it inside the uniques, right? So is this much code clear to everyone, what we are doing so far? So far all that we have done is we have created a unique array which is sorted and which contains unique elements only. After that, what I have done is I have initialized an answer variable to infinity, because if you remember my step, we were doing trial after trial. In each trial, whenever we were getting an answer, we were trying to check whether it is greater than a current answer or not. So we have initialized an answer variable which is plus infinity, and now we are literally going to consider each element of the unique array as our smallest element. So to start with, let's say I consider this as the smallest element. In that case, what will be my largest element? So if this is the smallest element, the largest element will be this plus n minus 1, correct? So what I have done is I have written a binary search method locate. This locate method takes in your vector of unique integers which are sorted and takes your target, and it is implemented in such a way that it returns you the last element, the last index of the element, which is smaller than or equal to the target. Can you understand this code? How many of you can understand this binary search code on your own? If by any chance you do not understand it, then you need to do some amount of work on binary search, which is a very basic topic of algorithms, right? So this has been written in a way that it returns you the last element, which is smaller than or equal to your target. Now once that has been, yeah, it's just like a lower bound, kind of lower bound. So once you know that index j, then do you know the length from I to j? So as I told you, what will be the length from index I to index j? It will be j minus I plus 1. So I can say j minus I plus 1 denotes the legal elements. Legal elements means those elements which do not need to be deleted. If these many elements do not need to be deleted, then how many elements need to be deleted? N minus 1. So if n minus 1 is smaller than answer, then I am updating my answer, and then finally I am returning my answer. That's it. So can you correlate the logic with the code? How many of you can relate this code with whatever we have discussed? But how they confirm that they are continuous? Array, it's confirmed, no, now. How is it not confirmed? Like if, let's say, you deleted the duplicates and this is what you got, and now let's say your smallest element is 6 and the largest element that thereby is 15. So you found out that yeah, from 6 to 14, how many elements are there? 1, 2, 3, 4, 5, 6. So you figured out that there are 6 elements in the array which do not need to be deleted, right? And if these are the elements which do not need to be deleted, that means you can simply go on to update the other elements and you will have your job done. So what you can do is, what elements are missing in this area? Tell me. 7 is missing, 12, 13 and 15 are missing. So you can probably make this as 7. You can probably make something else as 12, something else as 13, and something else as 15. This has 15. So ho gaya na kaam, the job is done, right? 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Did you get it? So if you simply count that how many elements are not to be deleted, subtracting it from the size of the array gives you, sorry, I keep on saying deleted. I mean, how many elements are not to be updated, then simply subtracting it from the length tells you that how many elements are to be updated. And that is what you keep doing, right? Awesome, great. What will be the time complexity of this approach? So you can see that sorting is involved, and sorting is going to take n log n time here. Even this approach can take you n log n time, because let's say the size of unique array is n, let's say everything was unique. Now every time what you are doing is binary search. So if you are doing binary search for n times, the complexity will be n log n, because each iteration of binary search or each invocation to binary search will take you log n amount of time, correct? Can we use map to store element index? I think that that's a very good idea, that you can store map to have elements index. When you have, even if you have done that, the precursor to that step will be sorting. Don't you think so? Sorting will always be mandatory, hai ki nahi? Because after sorting only you will be able to easily remove the duplicate element, and you will be able to conclude that yeah, this is the position of 14 in the sorted output, this is the position of 6 in the sorted output. So it will not have a drastic implication on the time complexity. It will continue to be n log n. The space complexity will be order n, because you are using an extra vector called as uniques of size n. Now food for thought for all of you is that when you go back, just think if you can solve this question without extra space. Yeah, I think Shivam, that answers your question also. Like instead of binary search, if you store the indices and all. You get the point, right? Okay, great. So it was a great question, isn't it? It was, to be honest, it was a beautiful question. In fact, I enjoyed coding it so that I could discuss it now. And such kind of questions are the ones which helps us become much better problem solver. But I'll tell you one final thing, that never ever take any statement as a statement of truth until unless there is a proof behind it. So this statement is very easy to give, but the proof of it is important, the proof that I gave you. So if you rewind everything, where did we start our journey from? We started our journey from saying that hey, n operations mein to hum kar hi denge. We can change every element to 1, 2, 3, 4, 5, 6, 7, 8 till n. And then we said that hey, that's stupid. We can fix one element and then we can change all the remaining elements, taking that element, considering one element as reference element. Now the next thing is that the element that we fix, I'm not sure whether it would be the first element or the last element, right? So how do we conclude that what is going to be our smallest element? Now, why did we discuss about smallest element? Because we know that the difference between max and min is n minus 1. So if we know min, we can figure out max. And if we can figure out max, then we can check in our array that how many elements are in between min to max. So there we talked about why the smallest element will definitely be one element of our array. And for that we took some examples. There we did the tedious part of the question. And once that was proved, then we were like, then everything was like breezer, isn't it? Why are we not counting the duplicate that needs to be removed? it does not need to be removed, it needs to be updated. So if you remember, here you had something like 22, which I updated to 7. Okay? And you anyways do not have to count duplicates. Just think of it this way, no? Like if somebody gives you an array which contains 1, 2, 2, 3, 4, then what do you do here? What do you do in this case? You change this thing to 5, and this is exactly what we are doing here also. Like when you only consider one occurrence of elements in your range, that means other occurrences are being considered for updation. So they will automatically be updated for the leftover elements that were not there in this part. The leftover elements were 7, 12, 13 and 15. 4, right? So 4 elements from this array, no matter what they are, will be updated into those. Does that give a lot of clarity? Yeah, that's great. Awesome. Cool guys, so go back, code it, and let's hope to meet again tomorrow with similar sort of interesting question. Sir, इतना कैसे सोच पाएंगे? लेकिन you don't have to judge yourself. I would say please don't judge yourself at this point of time. If you are learning things, these kind of questions could be tricky. Just go back with a sense of victory, I would say, because when you have understood a solution, then solution is not important. The small steps that we took towards the solution, they are important. And usually what happens is that people want instant gratification, right? So they are looking out for solution, like maybe it might be present in some sheet or it might be present on some blog, but they don't help. The solutions don't help. The small steps, really small steps that you take are the hard part. Writing the code is nothing. So when you see somebody doing that, like right now I was here to do that for you, then you learn that from the other person, and what you learn, that you repeat. Okay, so that is what is important. Do not chase the solution, do not judge yourself based on whether you could solve it or not. Judge yourself on the basis whether you could get some good traits of the one who was explaining you the solution. I mean, whoever he or she was. That is what matters in the long term, right? Right? How much time should we give to a single question? It depends upon question. For question like these, you can consider giving maybe 2-3 hours also, but I would say give that in break. Do not sit constantly for 2-3 hours. Once you have given 45 minutes to 1 hour, then you can take a break, move on to something else, and then probably take a stroll and then come back and then rethink. Okay, or probably you can discuss with someone, but do not sit whole day or 2 hours, 3 hours for just one thing, because your brain freezes and you are unable to unblock yourself. Cool then, awesome guys. Let's meet again tomorrow and keep learning. Okay, bye, good night.